Hi, everybody. Thanks for joining today. We're going to talk about a practice, an emerging practice called developer productivity engineering, and how we can use it to perhaps fulfill the myth of the 10x developer. If my clicker will work, there it goes. For those of you who I haven't met before, I'm Justin Reock. I'm the field CTO and Chief Evangelist at Gradle. My background is primarily in writing software. I wrote code for a good 15 years of my career. I did a lot of JEE stuff during that time. Moved into more enterprise architecture where I was doing a lot of integration and federation using platforms like Camel and ActiveMQ, which was good back then before Kafka came along. And so at some point I moved into really focusing on productivity, talking about how, for instance, taking open first programs within your business can enable developers to get started a lot faster. Got to the point where I'd go around and say, hey, you should use open source. Everybody was like, yeah, we know, thanks. So a couple of years ago, I kind of changed directions and started working for Gradle, talking about our Gradle Enterprise product, but it's not really my job to sell that. We have other people that sell that. I don't roll up to sales or anything like that. I roll up right to the CEO. It's my job to talk about this practice, developer productivity engineering. So if it feels like a sales pitch, please yell. Stop with the sales pitch, because that is not what I'm here to do. All right. So let's talk about the 10x engineer. I classify this sort of persona. I know I'm going to drive you crazy trying to move around. I'm going to try to stand still, but I'm pretty hyperkinetic. So anyway, I really do classify the 10x engineer as sort of cryptozoology, right? It's a mythological character that I put alongside the chupacabra or the yeti or the magical unicorn or the centaur, right? And I have some data to back this up, right? It's not just a theory. Apologies, by the way, if you believe in any of those. I'm not trying to alienate or anything like that. It's just my own belief system. So every myth probably has a kernel of truth to it, right? And that kernel of truth in this case is something called the coding war games. Anybody familiar with this study? Took part in a place in the 80s and was kind of envisioned in the late 70s. And if you want to see what the output of the study here, you can see that there's a white paper that's been published on it. And of course, if you need me to, I think you'll probably get the slides. I think is how that works. So you'll be able to get it later if you need to. So this was a study that took place. Was envisioned in 1977, but executed in the mid-'80s by two authors and researchers, Tom DeMarcos, Timothy Lister. And so from 1984 to 1986, more than 600 different developers took part in the study across 92 different organizations, so fairly decent sample size. The purpose was really to discover, what are the best and worst traits of software developers, right? How can we maybe isolate which are the ones who are taking practice that makes them highly productive, and which are ones that maybe don't so much. The competition unit was a group of competing programmers, so competing programmers within the same organization. They were not working together, right? They were working on their own, right? But they were working from within the same organization. A program spec was fixed, hey, solve this business problem using code, and then keep track of how long it took you to accomplish this. They used their own workspace, their own language, whatever they were familiar with, comfortable with. So there was no, boxing people in to use a specific framework. It was just work like you would normally work, and then record your results. And again, you can see the outcome of this here. Also, a great book came out of this. This is still, in my opinion, one of the best books for understanding how to build highly productive software teams by focusing on developer experience. And it's in its third edition. This book is definitely held up. And these are the two authors that I mentioned before who ran this study. And this became very much central to this book. So highly recommend this book. So what happened? Well, the best programmers in this study, from a productivity standpoint, outperformed the worst ones from roughly a 10x ratio. Okay, so far, looking like there may be a possible creature here, the 10x developer. Before we get into why, if we dig further into the data, we find out this isn't really true. We'll talk about a couple of interesting non-factors, things that you thought might have actually played into the productivity that actually didn't have much of an effect at all, didn't move the needle much. First of all, language. With the exception of assembly, programmers that were using further generation languages performed roughly at the same rate. A bitter pill to swallow here for some of us, especially me, years of experience. Uh-oh. The folks with about 2 years of experience were performing at roughly the same rate at 10 or more years of experience. The drop-off occurred around the 6-month area. Number of defects. Okay, so they're just cranking out code really fast, but writing really crummy, bug-filled code? No, actually, the top-performing developers in this study created defectless code. And then salary, another bitter pill, especially for some of you group contributors. It's about a 10% differential between the top performers in the study and the bottom performers in the study in terms of how they were getting paid. Okay, so what did matter? So paired programmers from the same organization performed at roughly the same level. Okay, so within the organization, people were really not performing all that differently. There was about a 21% difference between paired participants or grouped participants. And when you think about the 10-to-1 ratio, it's pretty much a rounding error, it's statistically insignificant, right? They didn't work together, but they came from the same organization. And the best organization performed 11.1x better than the worst, all right? So the 10x developer is supposed to be that developer in the single organization that's performing 10x better than other people in the organization. But this study bears out that's not really true. Developers working within the same organization were roughly equal in terms of their overall productivity. So this would lead Harlan Mills, a computer science professor at the time from my state of Florida, said, while this productivity differential among programmers is understandable, there's also a 10-to-1 difference in productivity among software organizations. Okay, so now we're getting somewhere with this. You can pull this URL later from the presentation. You can see the full white paper where he was quoted here. All right, so what's going on? Well, it appears that some of the best performers are clustering in certain organizations, while some of the worst performers, I'm really trying to not move too much, are clustering in other ones. And some of these companies are doing a lot worse than others, right? There's something about the environment or the corporate culture that's keeping good people from being able to be productive or failing to attract that type of talent. All right. So let's dig a little further into the data here. This is where things get, I think, pretty compelling. So when they were surveyed about sort of factors that would sort of characterize their experience, how they were supposed to work, the top performers answered much differently than the bottom performers in some of these more experiential questions, right? First of all, how much dedicated workspace do you have? Top performers, 78 square feet to work in, whereas the bottom performers were on 46 on average. Was it acceptably quiet? 57% of the top performers said yes. Roughly just a little more than half of those bottom performers answered the same way. Is it acceptably private? 62% said yes here. A third said yes in the bottom performing quartile here. 50%, can you silence your phone? Even back then, you may remember the big, chunky conference phones. They still rang, and you had to be able to silence them. 5 times as many people answered that they could do this versus the bottom performing quartile. Can you divert your call? 76% said yes versus only 19 in the bottom quartile. And finally, do people often interrupt you needlessly? 38% said yes in the top performers versus 76 in the bottom performers, twice as many. So sorry, Slack, surprise, surprise, you're not making us more productive. But really what you can pull away from this is that the phrase hadn't been coined yet, but this data shows pretty clearly that increased productivity came down to developer experience, right? For the organizations that were focusing on DevX and building a better working condition for their developers, surprise, surprise, their very human developers performed better in that case. So what can we say? That 10x organizations are manufactured, not born, right? They're doing intentional things to make their developers happier so that they'll write better code and be more productive, okay? So this matters even more now. Fast forward to 2023. IDC is not pushed. I'm checking like all the time because any day they're going to drop their 2023 study. So this is still a statistic that's a little bit old, but still kind of staggering. In late October, IDC predicted that 65% of the global GDP would be digitalized by 2022. And that came true. All right, now that was accelerated a little bit by COVID, but think about that. This 2/3 of the global gross domestic product is held up by software. All right, that means that this is now, us. This vertical is arguably the most important workforce on the entire planet, and so it's really important to start thinking about the experience of these workers. Most organizations are way out of alignment. I'll read this out. That's coming across terribly on the projector. Anybody familiar with Space Framework? Nicole Forsgren. How about Dora metrics? You've heard of those, some of you, okay? These are DevOpsy things that are starting to move across into the more kind of left space. The Dora metrics are the DevOps Research Academy. Dr. Nicole Forsgren, who is probably the premier thinker on this subject, she's who I want to be when I grow up, came up with the DevOps Research Academy, which was basically just what it sounds like, an organization that looked at people and how they were practicing DevOps and the impact that stuff had on their organization. Well, she sold that company to Google for like $1 billion or whatever, and went off to start another company where she's inventing a new productivity framework called SPACE. Now, DORA metrics are pretty focused metrics. They're things like, time from commit to deploy, or mean time to resolve an issue, right? SPACE is a bit more normalized and allows for, I would say, a wider lens in sort of exploring the productivity in the organization. Stands for, 5 things. You have S is satisfaction, all right? P is performance, which means like, are we meeting deadlines? Are we patching vulnerabilities fast enough? That kind of thing. Activity, this is just raw activity. Lines of code, builds, everything we're doing. Communication, collaboration should be self-explanatory, and then efficiency and flow. And what you're supposed to do with the SPACE framework is kind of in any way you choose, gather people's thoughts in the organization about how they feel about productivity, and then categorize their responses into one of these 5 dimensions, right? Now, the idea is to have a very balanced way of thinking across all 5 dimensions, but as you might be able to, as you might divine, it's not that way at all. Most organizations are not balanced that way. So here's a newer study, just over a year ago, between Microsoft and the University of Victoria in British Columbia, which is where Dr. Forsgren does her work out of. Developers and managers were surveyed on their interpretation of the SPACE framework. They asked kind of the same question to managers and developers, and the answers were very much out of sync, okay? So developers were asked, when thinking about your work, how do you define productivity? First big bad thing here, look at this. Developers and managers are both single digits in terms of responding anything about job satisfaction. I mean, isn't that crazy? Like in almost every other field, you would talk about either satisfaction or impediments to satisfaction, right? But for some reason, we're like masochistic. We don't think about our own satisfaction. Maybe because we get paid too much, I don't know. But anyway, so that barely even came up. So we're going to talk about that because we got to improve that. Here we go. Managers were almost twice as often to think about performance, so meeting deadlines and meeting the goals of the business, than individual contributors or developers, which says that developers may not really have an idea fully of their impact on the business, right? Which is important to have that. It's a motivating factor to know that you're bringing value to the organization. Finally, activity, right? IC is defining on productivity. 50% developers are just like, nope, lines of code, builds, that's what I'm doing, builds, lines of code, right? Whereas managers were only down at 21%. Collaboration, we're okay here. I think we kind of understood that. And efficiency, I guess everybody at least thinks about efficiency, so that's good. But these are still way out of balance, right? This differential right here really needs to close in a little bit, as does this one, and this has got to get improved. All right, so we need to improve productivity, we need to improve developer joy, but we're not even speaking the same language in terms of the leaders in the business who actually have the authority or whatever it takes, the gravity to be able to implement strong cultural changes in the business, and then the folks who serve to benefit the most from those changes in terms of their job satisfaction and ultimately their productivity. So the only initiatives that we know this is business science, that are going to positively impact performance are ones which increase throughput while simultaneously decreasing costs. If you've ever read The Goal or the Phoenix Project, or any of the Agile DevOps Playbook, or any of the things that were derived from looking at what's called a value stream and understanding how do we actually improve the health of the business, we can look at costs all day, layoffs or whatever, we're seeing them all over the industry right now. But if there's not a simultaneous plan to increase the productive output of that business, that layoff is just a Band-Aid. It's not going to fix the problem, right? Throughput is way more important than cost. Throughput is effectively how fast can our developers write code that the business can then turn into money for the business, and what is the gap between those things. And if you think about this mindset, this is a lot of where DevOps came from, right? I mean, I come from the day where it's like you compile an artifact and you like copy it to some drive and you like walk it to another building and you hand it to a QA team and they try to install it and they can't, so they call you and then you have to walk back over there because they weren't installing it the right way, and then like 3 days later they've like tested like half of it and it's all broken. And I mean, that's now what do we have? We have automation, right? We can take this stuff for granted. We've got CI/CD that can, notice a commit and run all of our tests and run a lot of automation to make sure it passes acceptance, and then go out to production. And even when it goes out to production, it only gets shown to like 1 in a million users in a canary or a blue-green release, right? And if anything breaks, then we just back it out, right? But it was not that way. But this mindset, this closing the gap between the work that developers are doing, the cost, and the throughput for the business has been the focus, right? And the thing is, DevOps has helped a lot with the one side of the loop, helped a lot with having to walk the sneakernet code over to the QA team. But we still have these massive bottlenecks and impediments to productivity that are just living right in the developer experience now. We cleared some primary bottlenecks with DevOps, great, but we just sussed out more primary bottlenecks. That's kind of what we're going to talk about. So yeah, I mean, DevOps 12-factor Agile, they've just not captured all the bottlenecks of productivity here. A lot of these are just hiding in plain sight. We're going to go through a lot of these specifically. But a 10x organization needs to think about reducing build and test feedback cycle times, improving the consistency and reliability of builds. All right, so we need to make build and test cycles faster, and really we need to make them as fast as they can be. We have to keep them fast, and we also need to pay attention to other things like avoidable infrastructure failures that developers have to wait 15 minutes before encountering in their test cycle, or flaky tests, everybody's favorite thing to deal with, right? So it is time now for this practice of developer productivity engineering. I mean, it's just quite literally time, right? DevOps has been fairly well commoditized. We're seeing the commoditization of the platform engineer, right? And we're just marching further and further left into the developer experience, clearing impediments to productivity, right? So when we say this is like the time for this, or the next thing after DevOps or platform, it's like quite literal, right? It's about chasing down the next set of primary bottlenecks. So yeah, I mean, if you look at all these practices, talking about throughput and versus cost, this is what all of these successful practices have had in common. And going back to the 70s and what I like to call the ancient business wisdom of the 1970s and 80s, just-in-time manufacturing, business process reengineering, and change management. Then right here, software ate the world, and this became less about manufacturing and more about manufacturing code. So we ended up with Agile, Lean Six Sigma, ultimately DevOps. We got this weird platform engineering thing happen in between, but what we're seeing is a weird microeconomic where DevOps engineers are becoming platform engineers, are becoming productivity engineers. If you look at the career path for a lot of the folks that are doing this at scale at companies like LinkedIn and Netflix and Twitter and Uber, these are some of the companies that I'd say are the premier scaled productivity organizations. They didn't just pull productivity engineers out of nowhere. They took folks who were, again, in that DevOps SRE role. They understood metrics. They understood monitoring and observation. They put them in platform. They started building scaled platforms for developers. And then they put them in productivity engineering because it turns out that's what they were the whole time. So let's talk about DPE. When I talk about DPE, I like to start here, right? Because I think we really have to acknowledge that software development is a highly creative process, but also a highly scientific process. It's this weird kind of merger of both sides of our brains, right? On the one hand, we're doing something very creative. We're envisioning a problem that we're trying to solve in our head. We're envisioning a structure or a model to try to solve that problem, or maybe we're whiteboarding it, whatever we do. But then we do something kind of interesting. Then we do something sort of scientific. We have a dialogue with the tool chain and we presented a hypothesis. And we say, hey, I think this code that I just ran is going to solve this problem. And then we rely on feedback from the build system, that's the other side of the dialogue, to tell us whether or not we've done the right thing. And when it gives us that feedback, whether good or bad, we know that we're clear to move on to the next feedback cycle, right? And what is developer experience but just a series of feedback cycles, right? And so these feedback cycles are key to the experience. On the one hand, look at these kids. They're happy. Maybe they just ran their first system out.println hello world, and they click go, and it showed up on the screen. Or if they were smart, they used Kotlin, and they just said println hello world. But anyway, either way, they just click go. Pops up on the screen, feedback's immediate. Yeah, wow, dopamine hit. This is exciting. I'm loving this. I'm ready to learn the next thing. We've been here. We know what this state of creative flow feels like. We know what it's like to be able to have uninterrupted and unimpeded focus on the work that we're doing, and we know how ecstatic that feels. We know how great it feels. And it's not just me saying this. The brain has been mapped, experiments have been done, and it's this wonderful soup of left brain, right brain, all this stuff activating in the brain while people are writing code. That's why it feels so good. But I want you to imagine that these kids are waiting 30 seconds, or a minute, or 10 minutes, or an hour, 10 hours, If you're the Apache Tika project, 48 hours to run your full corpus of tests. You're not gonna look like this, you're gonna look like that, and you're probably gonna go find another career or hobby, right? But so why do we put up with this then, right? How come it's still, we feel like this is just an occupational hazard of the job for us, that we have to put up with the same toil and frustration that pulls us out of our state of creative flow and limits our joy? We don't have to anymore. We need to get out of this, right? You know, we're coding, we're happy, and a lot of people look at this like, God, I wish my schedule looked like that. Where's all the meetings? There's kind of a sprint right here, you know. But I'm not here to help you fix meetings. I'm here to help you fix your tech. So, excuse me. So what do? We wake up, we're coding. We're happy, we're in our flow state, we're great. And then we're waiting for our build to complete. Then it fails. And just because the build failed doesn't mean that we're going to be taken out of a state of flow. It's just another problem to solve. Build's red, fine, problem. What's going on here? But if we're spending 45 minutes or an hour trying to debug this failure because we don't have enough visibility, maybe it failed in some weird CI environment, we don't even own that, and it was some ephemeral build environment, so it destroyed itself like 20 seconds after your build failed, and you're going to spend the afternoon just slapping with people. I mean, it's just awful. You're playing 20 questions. So then you're frustrated, but you finish your debugging, you go play lunch, or maybe you're playing Elden Ring or the new Zelda, I don't know, ping pong, whatever you're into. And then you come back and you're coding again. Yay, happy time. And we're waiting, but our build completes. So then we push it to CI and wait again for the CI build to fail because tests are flaky. The tests that we're succeeding in our local environment are failing in CI. So now, yay, we get to do what we all love to do, spend the rest of the afternoon debugging a flaky test. All right, it's 2023. Developers are the most important workforce on the planet. It is time to fix this. It's time to get out of this. I love this cartoon. This cartoon is hilarious, right? We've all seen this, but it's also really sad, you know, because it's true. Number one programmer excuse for legitimately slacking off, my code is compiling. Or, you know, we can say this one too. You know, that works also. In fact, nowadays, the big enterprise projects are probably spending 90% or more of their cycle times just in test. I have a sinking feeling we might be getting here. Yeah, I wish that wasn't true. Guilty like everybody else, I'm sure. I paid my $20. It's not down for me anymore, so. So before we really dive into this, let's make sure we're super clear on what we're going to be solving when we look at some of these actual solutions. I'm trying my best. So again, here's a developer in like a local environment, remote environment, CI environment, doesn't really matter, right? And you can imagine these things floating around that developer are feedback cycles, okay? And sometimes things are fine. Sometimes they take too long. Well, we talked about that a bit already. Sometimes they take too long to fix. We addressed that as well. And then the worst one, something that we could have avoided altogether if we were just applying the right analytics and observation, right? Our avoidable failures and our flaky tests, okay? So let's talk about faster feedback cycles for a minute. We know that they're important, and there are some intuitive reasons that we know this, and some not so intuitive reasons, right? So let's kind of go through what happens when we improve our feedback cycle times. What are the cascading impacts to a dev organization when we do this? Well, the easy one, less idle wait time. Sure, you know, we can focus more on our work. We're not interrupted in the middle and off, you know, checking our news feed or whatever we do. So that makes sense. But what does this also really mean? Less context switching, all right? Less switching between multiple tasks. We've learned a lot of interesting stuff about the neuroscience of multitasking and context switching over the last decade, right? Over the last decade, we figured out, first of all, it's a lie. Nobody can actually truly multitask, right? We may be able to switch rapidly between things. We may be able to convince ourselves that we're multitasking, but we're not. Our executive functioning in our brain's just not wired to do that. But within the last couple of years, we've learned something even more compelling. Not only can we not do this, but it is deleterious to our executive functioning to do this. It is toxic and bad for our frontal cortex. It leads to an increase. It's associated with an increase of glutamate, a toxin in the prefrontal cortex, which is directly related to cognitive fatigue and stress. And the thing about cognitive fatigue is that it's real slippery, right? When you're dealing with somebody who's cognitively fatigued, they can still do basic tasks. They're getting the job done, the code is getting cranked out, but nobody's elevating the work, right? It's really hard to innovate when you're cognitively fatigued. It's really hard to think past just the task-rote work that you're doing. So this reduction in context switching literally has a direct impact on that team's ability to innovate. And it's a don't know what we don't know kind of situation, right? So we just need to eliminate it as much as possible and then see what happens. All right, so this leads to more focused developers, better productivity, better quality. Now, the things that we don't always think about. If your builds are faster and your tests are faster, you're going to build more frequently, which means that you're going to be able to receive feedback about your work more frequently and in smaller change sets, right? So instead of cramming like a bunch of code in because we know we got to wait an hour, and then any number, 20 new breakpoints have been introduced, so it's going to be really hard then for us to boil down what actually caused our build to fail. Instead, we're allowed to now push smaller change sets, which leads to earlier quality checks, fewer downstream incidents, fewer merge conflicts because we have a much smaller surface that we're merging, more efficient troubleshooting, and a faster mean time to resolve, which boils again to quality and productivity. Okay, so it's important to think through all of the cascading impacts of doing this. It's one thing to say that we should improve these. It's another thing to really understand why. So let's get into some solutions. That's a lot of theory. What can we do about this stuff? Well, first off, build caching. Right? Build caching is not dependency caching. Let's get that out of the way right now. If you're thinking, oh, we use Artifactory, we use Sonatype Nexus, those are great products. It's not what we're talking about. Those things are caching individual dependencies. I'm actually talking about caching chunks of your build, chunks of your artifact, so that those steps of the build, if it's safe and if we can get a legitimate cache hit, don't have to be repeated. So this was introduced to the Java world by Gradle in 2017. It is still turned off by default, just FYI. You actually have to go into your Gradle properties and turn it on. Maven has an open source build cache now that's generally available. They released it back in, I want to say end of October, early November. I played with it, it works. And it's used by leading technologies like Google and Facebook and can support hopefully user local and remote caching for more distributed teams, right? Great to be able to cache parts of your build locally on your laptop. Even better to be able to have a remote team that's making changes overnight, populating a cache that you can potentially benefit on your first build of the day. So your first executive decision of the day is not to wait an hour, but to actually have a fast build that you can start working with immediately. Again, they're complementary dependency caches, not mutually exclusive. If you take one thing away from this talk, build cache is not a dependency cache, but they are complementary. So how does this work? Well, at least in the Java world, Gradle tasks or Maven goals are organized into a set of standard inputs that go into that part of the build, that goal in the case of Maven or the task in the case of Gradle. Then something happens with those inputs. Maybe we're compiling code. Maybe we're running a test. Maybe we're doing a check style. Maybe we're linting something. And then the output of that is produced. This could be a tree of compiled class files. It could be a JUnit XML report. It could be any of these things that should be an output from that phase of the build that ultimately will get included in the finished artifact, right? So when the inputs have not changed, we can just reuse the outputs from a previous run. We can do this safely because we do this in a very sensitive way, right? We are creating a cache key out of things like the source files, the JDK version, the class path, compiler arguments. And so if any of these things change at all, like even if you've got something like generating timestamps, like in a properties file or something like that, that'll cause a cache miss because it's that sensitive. Was there a question? No? Okay. So anyway, what we're doing then is creating this hash from these things that if anything were to change about any of them, we would no longer be in a situation where we could safely pull this part of the build from cache. But in this case, so it is very sensitive. But when we do have the exact same set of inputs, right, when we do have something that hasn't changed at all, we can safely pull this from cache and not run that part of the build. Now, depending on the modularity of your build, this can have some impact. This can have lots of impact, right? We've seen like 90% out of the box savings, sometimes even higher, depending on how modular the build is. So plenty of information on how the build cache works here. I don't have the link for the Maven open source build cache, but it's very easy to find if you just search for it. If you're not using Maven or Gradle, Bazel has a build cache and a remote distributed cache. If you are on the JavaScript side of the house, there's also like, I forget, there's a cache in NPM that lets you work. The getDX folks are all about it. If you're building native C, there's Clang, GCC, all these things have build caches. The thing to do is to seek them out and start using them, right? Figure out how viable they're going to be for your project. So lots of things are cacheable in Gradle and Maven, right? We've got tests and we can compile all these different inputs and check style inputs like source files and everything like that. It's generic. and really can apply to anything that's not I/O bound, right? Like obviously you're not going to cache like packaging in a jar, right? But for compile tasks, for check style tasks, for test compile tasks, like these are all legitimate and can usually be cached if they're normalized. So let's walk through kind of a code example here, sort of. Let's say we've got a multi-module build, right? And we got 4 modules for the sake of kind of easy explanation in this one, right? We got core, service, web app, and export API. So if you're setting up in Maven, your POM might look like this. If you're setting up in Gradle, your settings.gradle file might look like this. And the thing to understand is really the dependency relationship here. So core is kind of the most impactful module, right? Export API depends on core. Service depends on core. Nothing depends on export API. Web app depends on service, and nothing depends on web app. Okay, so that's the dependency relationship that we have here. So under normal circumstances, either a Gradle clean build, because if those of you who are familiar with Gradle know that we are an incremental build system, which means that we can skip tasks that have been repeated recently, but only if they've been held in the daemon. There's some limitations there. And it doesn't work on a clean build. If you're running a clean build, all the incremental stuff is just skipped. So this is talking about the value for a clean Gradle build, or really for any Maven build that doesn't have caching turned on, right? So under normal circumstances, I change anything here, I got to do all of this. I got to run all these steps, all right? But if I'm caching, what happens if I make, say, a change to a public method in the export API module here, upon which nothing depends? Well, it's a public method, right? So it is an invasive change. But because nothing depends on it, all I have to do is compile it, compile its test, run its test, check style the code. Everything else can be pulled from cache and not repeated. Okay. What about something a little bit more invasive, like a public method in the service module upon which web app depends? Well, it's a public method, so I got to do everything for service, compile it, test compile, run the test, check style, and again, public method. But at least I could save on the check style here on the dependent module because I haven't changed any of this code. I still have to recompile it, run the test compile, run the test, but then all this stuff I can pull from cache too. All right. What about an implementation detail? Instead of a public method, but an implementation detail of the method inside of the service module? Well, I got to compile that. I don't have to compile my test because it's an implementation detail, not a part of the public method. I do have to run the test. It's a good thing to do. And check style the code because I did change the code, but I can even pull this part from cache. I got to rerun the test for the web app, but again, implementation detail. Don't have to recompile the test, run the check style, run the compiler, any of this. And all this stuff I can pull from cache. Starting to see how the possible benefits here. So the more modular the code is, obviously, the more impactful it's going to be. But it usually doesn't hurt to at least turn this thing on and see what kind of savings you're going to get. And like I said, it is part of the Gradle open source build tool. It's just turned off by default. org.gradle.caching equals true in your Gradle.properties. Or if you want to check out the Maven one, open source. I don't remember their instructions offhand, but it's super simple. You're just dropping another extension in. Okay, and then a better architecture than, this is all talking about locally, like on your laptop, right? Caching chunks of the build, which is great for local builds. Build local, right? We believe in this. But what about remotely distributed teams? What about folks that are checking in changes to feature branches or whatever all overnight? So you're pulling down a whole bunch of new code in the morning, and it's not going to match what you had in your local cache, right? Well, a good architecture is to distribute the cache, right? This is built into Bazel by default. Gradle, you can actually just pull down a Docker image of a remote cache node and you can set it up yourself. And the way that this works then is that the best architecture is that remote developers are populating CI. CI is running the build, and then CI is populating the cache, right? It's linked directly to the build tool, so it doesn't really matter whether this is happening at the local workstation or whether it's happening, whatever's running the build tool is what has the opportunity to cache. Then it's going to stick stuff in a remote cache, and guess what? Developers, first thing of the day, they pull down all the new source code from overnight. CI has been populating the cache with that new source code, so they actually can get cache hits from remote cache, and our first build of the day is not a miserable hour-long thing that we have to suffer through. It's, in fact, we can just kind of get right going, okay? So that's caching. Test distribution is the next leg of this, and there's multiple implementations. We were just talking about test containers. Test containers gives you the ability to do this. It's actually not that hard to build using a Kubernetes substrate with built-in elastic scaling in Kubernetes, which is what I'm going to explain here. But the idea is that we want to be able to, as much as possible, allow tests to run in parallel. Now, a lot of build systems will let us do this locally, which is great, or we could come up with hacky solutions like CI fanout, where we're manually partitioning sets of tests and building a parallel pipeline. But it would be even better if we had some intelligence that was built right into the build tool that allowed us to schedule these tests in hopefully a cloud substrate, and hopefully a substrate that's elastically auto-scaling, which is exactly what we recommended. So the way that this architecture works is that you have effectively test distribution agents. Now these are just usually stripped down Linux Docker images with a JVM running on top of them, and some test framework, JUnit, whatever it is that you need to be able to execute that test. And effectively, you're running your tests from the local or CI build. You're pushing it through some sort of auto-scaler that's then scheduling these tests to run on one of these remote agents, and the agents report the status of the test back directly to the build client, which is great, right? I mean, if you've messed around with CI fanout to try to fix this problem before, you know that one of the toughest problems is actually reconciling the test results back. And so this fixes that problem because we're skipping that. I mean, sure, you can run this out of CI, but it's still linked directly to the build tool. So that's key for looking at any of these solutions, right? And like I said, there's open source stuff like test containers that can do this. There's existing solutions like single machine parallelism, that's there. This is an example of the CI fanout that I mentioned. So you can see here we're running a test group 1 task and a test group 2 task and a test group 3 task. But we had to manually partition this and we have to figure out how we're gonna get our results back. And so much better to use a solution like test distribution. Build caching is great, but what about when things have legitimately changed and we're getting legitimate cache misses, right? That doesn't help us during this phase. Single machine parallelism is, of course, limited by your Mac. Even if it's an M2 awesome new Mac, it's still limited. I mean, if you've got, the Kafka open source project, for instance, runs over 24,000 tests on its full cycle, right? I don't care how parallelized you are, that's gonna take a long time, right? In fact, I've cranked it up, not on my M2 Mac, but I've cranked it up on, and it's like 45 minutes or something, even running tests in parallel locally. And then finally, CI fanout doesn't help during local development at all, which again, build local. And you need to manually set up your partitions. This is just totally broken when you have ephemeral CI agents that are destroying themselves because they can't cache, right? And they even will have to probably download dependencies each time, right? So much better solution with test distribution. If you're interested in seeing how again, a very productivity-focused company, in this case Netflix, I really do consider them amongst the upper echelon of companies that are really doing this and doing this at scale, right? You can see here how they were able to use a combination of the build caching technology that I mentioned and test distribution to bring a 62-minute test cycle time down to under 5 minutes. Now, this is based on an interview with a guy named Danny Thomas, who, again, one of the principal productivity architects, productivity engineers at Netflix. In this interview, and I can't remember, I think we actually have this called out in the article, but he said something that really stuck. It's been very motivating, but I think is also really just gets at the essence of a lot of what we're talking about here. He said in that interview, it is staggering the amount of toil and friction and frustration that engineers are willing to put up with, right? And I mean, again, it gets back to what we were saying before. Why are we putting up with this? I just don't think we're not complaining enough. I mean, we need to make a little bit more noise about this. Okay, and finally, for our last sort of recommended acceleration technology that you look into, we'll talk about something called predictive test selection. Anybody heard about predictive test selection? Aha, of course Pratik has, because we've talked about it over beers. But this is not something that Gradle invented, right? This came out of the labs of Facebook and Google. Meta published a paper about this back in 2019. And since then, several companies have successfully productized it. But if you look in Meta's research paper about this subject, you learn soup to nuts how to build this thing, from scratch, what type of model you should use. It's an open source model called XGBoost. So if you know about XGBoost, it's not deep learning. It's a gradient boosted model, so you can put it next to a CPU. You don't need a GPU or anything like that. But it also hits a couple of important use cases that Gartner has called out recently for using AI in software development and testing. Probably hard to read. This one says test set optimization, and this one says optimal test selection. This is slightly different, but getting sort of, of course, the same thing. What is it? I mean, it's really just a new approach to test impact analysis. Like I said, it came out of the labs of Facebook in 2019 and uses machine learning to build a predictive model to determine which tests to run. It looks at a history of test behavior, and it trains itself on a number of different features. like the number of tests and the number of times that this test has failed in the past and how recently it's failed, a lot of different features. And when it's about to run the test, or when it's been instructed to run a certain test set, it runs it through the model and says, hey, before I do all this, can you come up with a score how likely this test is to fail? How likely this test is to give me feedback that actually matters? Because I could be a Kafka developer and run 24,000 tests and wait 45 minutes for them all to complete, and I could give myself a nice pat on the back, but that was a waste of time, right? I didn't need to really know that they were all going to succeed. I really needed to know which ones were going to fail in case I broke anything, right? So this predictive model does kind of exactly that. It looks at the full history, and it looks at sort of the current context of the build now, and it says, okay, based on everything that I've seen in the past, this test has a 99.9% likelihood of just passing, so don't run it. Pre-merge, let's be careful, right? Post-merge, run everything. But pre-merge, this can be really helpful in your local experience and in all the things that are happening before we're actually, issuing a PR and doing a PR build and all those things. So, basically runs will do the work of running tests that are either going to pass or be flaky. Actually, the model calls for filtering or quarantining flaky tests too, or ones that are predicted to be flaky. So in the flow is pretty simple to understand. Pass in a code snapshot. Sorry, I meant to wipe that out. But you pass this through a predictive test selection model, which is going to look at this full history. And then it's going to select, okay, you only run these 3 tests. Then it's going to run it, return the results, and then use those results and return them to the build itself. And then pass these results back into the updated model. So it's also continually retraining itself, right, which is part of the specification. But it's easy to do because, again, it's an XGBoost model. It doesn't take long to run this prediction. Okay, so those are kind of the 3 acceleration technologies that we kind of recommend. We need to start wrapping up here pretty soon, but we're getting near the end. We mentioned troubleshooting takes too long, right? We don't have all the information that we need to troubleshoot. Without getting too pitchy here, we do have a free service called the Build Scan, which will pull in a whole bunch of forensic details about your build and sort of give you this nice shareable interface for grabbing details about what took place in your build. The idea is to provide like a self-service solution for developers to be able to get all that data that I was talking about before, where you're going back and forth with people who actually understand the environment. We're sucking all this forensic data into a single build, and it exists for free for Gradle and for Maven. We're working on a freemium for Bazel. Yeah.
So these build scans, right? I've used them in the past. So are there any Docker images? I'm not able to get any Docker images where I can test the scans locally. I have to go to the cloud, right? Like,
yeah.
I have to get to the cloud, but there's no like a service that I can.
Yeah, with the freemium, it's kind of self-service. But what I'm going to do, there is a call to action at the end of this. We have a fully public server that you can just like play with.
The problem is like most of the builds that we do is like
sensitive.
IP and we cannot.
Yeah. I mean,
unless we have a.
So this is a pain that we're actually working. We just were talking about this at our world meeting last week. Was the ability to be able to provide way more of like a self-service experience for these. So it's on the table. Like we.
That's the main reason.
Yeah.
I know this is a very good tool. I've used it in my open source project, but I cannot use it in enterprise.
That's a legit complaint. I mean obviously it's a path to sale for us. I mean self-hosted is like the commercial version. But we are working on another freemium where it's like, yeah, you can try this for free on your own prem, download onto your laptop and then delete the whole thing if you need to. So it's on the roadmap. We know that this is missing. So yeah, of course. All right, performance continuity. So we sped up our build. Great. What happens next week when we introduce an annotation processor and suddenly the build went down to half the speed it was at before? Because all kinds of things can sneak right back in, right? I mean, binary management, changes in caching, differences in CI agents, new office locations becoming more and more relevant, right? We need to be keeping track of how these speeds are, and we need to do this continuously and with rigor so that we know that if the build was 30 seconds on Tuesday and 5 minutes on Thursday, we can box in a window of time and say, okay, here's where the build regressed, right? Because sometimes it's in your face like that, sometimes it's not. Sometimes, this new thing added 5 seconds to the build, this thing added 10 seconds, this thing added 20 seconds, and then before you know it, that builds back up at 15 minutes again, right? We've got to keep an eye on this. So this is where I ask a provocative question. Who is tracking local build times? One person, two people, three, four. Ooh, this may be a record, right? I usually get, no, I'm not kidding. And even in front of DevOps crowds, I was just doing the keynote at DevOps Days, Birmingham, Alabama. Vincent was out there with me just a few weeks ago. I asked this question to a crowd of 250 people. One hand went up in the back, right? But this is like the most important metric, right? I mean, like if you're going to track one thing, and in fact, that will be my takeaway that I recommend. A lot of people are like, how do I get started? Just start doing this. It's not hard. It's super easy to build like a tiny plugin or whatever for your build system to just go and take the build time and push it into something like a Prometheus database. Because I guarantee you, if you start tracking this, you're not going to be able to unsee it. It's going to be bad, it's going to be inconsistent, and you're going to have something visual that you can then use to drive better productivity within your business and start keeping track of some of these other things. So this is just a picture of what that graph might look like. Here's 463 builds. Keep track of your avoidance savings too, because that becomes the return on investment that you get to show to your boss about why we did all this stuff. So we got to get out of this mindset. This is the mindset we're in right now. This is the wrong mindset. We're asking the question, oh, is the build fast enough? Is it acceptable? No, that's the wrong question now in 2023. Is it as fast as it can possibly be given all acceleration, analytics, and observation technologies, because that is what we owe this workforce. Okay, how about consistency? Oh, well, no surprise here. We surveyed a whole bunch of folks who are doing this at scale, like the Netflixes, the Twitters, the Ubers, the LinkedIns, and found out that 81% of survey respondents said that DPE just made their job more enjoyable, okay, which is really what we're trying to do. Developer joy equals developer productivity. We don't see a difference between these two things. And it's not like 19 people like, no, that's not true. They were like, neither agree nor disagree. I don't know what DPE is. I didn't know we were doing that. But still, pretty good response there. All right. DPE organizations, 10x organizations, we eliminate avoidable failures too. And we can do this by tracking and aggregating, right? Not that hard. When a build fails, that same little plugin that you wrote earlier to track your build times, grab that failure and stick it somewhere, right? See how often this one failure or similar failures are impacting your developers, right? Did this one failure impact one developer over the last month? Or did it impact 18 developers over the last week, like you see in this picture? So if you have an hour to improve your build tool chain, what do you work on? Right now, most of us probably don't know, not with any type of data-driven or educated way. Remember, oh, last week, so-and-so was complaining about this thing, and they were really mad, so I should probably go fix it. But we don't know that that is actually impacting other people, right? So aggregate. We call this failure analytics, right? But when something fails, aggregate it and be able to pull this type of analytics, because then you know where you should spend your time to make the most impact. Dealing with flaky tests. We can do the same thing here. This is what we do now. Yeah, but we all do it. I mean, come on. Flaky test, I'm just gonna run that one. Or, oh, finally it went green, good, done, I'm going home. So, actually not a hard thing to analyze either. First of all, if we're using caching, we get a shortcut. Just keep track of those cache keys. Anytime that you run across a test in your build, keep track of that cache key and the output, because guess what? If you run into another test with the same cache key, same set of inputs, and sometimes it fails and sometimes it succeeds, flaky, right? Worst case, although this also works too, you can easily spin up a plugin, and some of these already exist, to retry the test every time it fails. So that you usually don't have to think about doing that manually. And then set a threshold, like, okay, if it failed, run it again. Did it fail again? Did it fail again? Okay, fine. This is probably an okay test, right? But the best is if you turn on caching and you do your key comparison, because you can do that at much larger scale. And then, all of this will impact CI. Now, a lot of our developers were like, we don't care about those CI people, and the CI people, we don't care about those developers. But the truth is that we should be thinking more about the impact that we have on CI. Like, for instance, flaky test, what did we do? We ran that test like 10 times, all right? If we scheduled it 10 times in CI, that does impact CI, right? Or also build failures. For us, if we have a build scan so that we don't have to open up a ticket with CI, that's less support work, and then they can focus on what they want to do, right? If you think about this again, just running things less often is going to mean more agent freedom, but also having the cycle times being faster per agent. It may not decrease the overall queues because, again, hopefully developers are running more often, but it makes those runs way more valuable, right? Getting way more bang for our buck in those CI systems, especially cloud ones, are getting expensive. Okay, so all of this is to say that DPE will become standard practice because the world should foster developer joy. It's good for the whole world, right? The reason that I do this is because I really think about and ponder the global impact If every single company were able to crank out software and innovate because their developers are not context switching all the time and cognitively fatigued, but innovate at 10x the pace, what does that do to everything around us, right? I mean, maybe it finally gets us our Apple AR glasses. It's like, oh, I really want this. Or robot bodies, hello, anybody? Anyway, there is a global impact. We just all need to be practicing this. So what are some next steps? Well, I mentioned before, the DPE organizations build focused teams. This underscores a major difference between DPE and DevOps, right? DevOps organizations, the platonic ideal is nobody at all bots and automation, right? But for a DPE team to be really successful, you have to have that empathy and that understanding of developer experience, or you won't have urgency to push these initiatives, right? And build a focused team. Don't make it the part-time job of one heroic senior developer to spend 2 hours a week on productivity, right? Make this a focus, right? That's what the teams that are doing this at scale have done. We got something cool that we are piloting tonight. We literally finished this like an hour before the talk. Vincent and I were hacking away at this thing. If you want to learn more about DPE, if you want to go through the vendor agnostic materials that we have around this practice, not only is this platform free and self-guided and self-paced in terms of taking kind of your journey through your knowledge, but you get rewarded for it. You're going to earn, it was like 2,000 points for completing kind of the first set of challenges here, which you can use to turn around and spend on some nice swag, right? And once you make it through sort of the initial set of challenges, you'll get opened up into the full platform, which you can use if you want to help boost our acts of advocacy. But I'm really excited about this. I mean, a lot of times people have come up and they've said, like, how can I learn more? And I'm like, well, read our book, or I'll come do a Zoom for your team. But this is way nicer. You can complete this at your own pace. And like I said, you can get rewarded for it. Okay, cool. What else? OSS projects were up by Gradle Enterprise. If you go through the advocacy journey, you'll get a chance to see this too, but you can also just pull it up from our page. We have about 18 open source projects that use our technology for free. So we just give them instances, so like Spring, Spring's got it. Actually, you can see it right here, they're at the top on the list. Kotlin is building against this now. Open Rewrite, Micronaut, test containers, right? They're all building against this platform. The reason I bring it up in this context, it's a nice way to get inspired about what real projects are doing with this data that I just mentioned, right? How are these projects that are building thousands of times a week, what data is important to them? How are they presenting that data so that when you go back and think about implementing some of these things on your own, you could use this as inspiration. What's important to Spring, what's important to JetBrains, these folks. There's a book for this too. Again, it's part of the knowledge journey. You'll see Gradle on the front. You won't see it again throughout the rest of the book. It's vendor agnostic, platform agnostic, just an 81-page second revision handbook on how to do DPE at scale. I'll let you finish with the QR code scanning. Oh, that almost finished. Thank you. Appreciate the interest. And of course, if you want to catch me at Taco Mac for drinks afterwards, I can hook you up with the link. I don't want to stop yet because I'm kind of like everybody. We're like a rolling thunder here. All right, I think that's everybody. Because that's it. So thanks very much. I really appreciate it. Thanks.
Any questions for Justin?
Hardest questions get the swag.
Or the only question?
I guess we're at that point too.
We have more swag than just that.
Oh yeah, we got shirts. These were the speaker shirts.
We all remember Star Trek: The Empire Strikes Back, don't we? That was my favorite Star Trek. Got the ATL hat. Dev Nexus.
We also have a book.
Aha, what do we got?
My question is easy. It's the DPE. Is that a buzzword or is that really some kind of industrial trend? We know DevOps. That's definitely something like everybody was already on the journey. Or
that's why I'm here. So we already have a few other companies and partners that are starting to call it DPE. Say over the last 4 years, you're starting to see this emerge as like an accepted term. But it's mostly been in the Bay Area tech companies that I mentioned before. You go to Netflix, Twitter, LinkedIn, Uber, they know what developer productivity engineering is. They're practicing it, they're calling it DPE. We're working now to bring in even more partners into the space. You could say that's kind of my prime directive actually, is even less about making sure that people buy Gradle Enterprise and way more about the industry recognizing this as a term. So Are we there yet? Commoditized? No, I've still got a lot of work to do.
Okay, thank you. Sure. And also you mentioning about like reduced build time and reduced testing time. There are some techniques introduced there. How does that compare with some other companies? Disclaimer, I didn't use any of those products, but I heard some company like called Electrical Grade or something. They claim many years ago, they claim they speed up your build process.
X-Rebel or J-Rebel?
No, Electric Cloud or something.
No, I'm not sure. So let me say this though. I mean, oh, absolutely. If you are concentrating on the tool chain, if you're concentrating on improving and measuring the technology, or I've heard it described too as treating your development environment as a production environment for your developers to write code, right? If you're instrumenting that part and you're improving that part, it is DPE, right? That's why we're trying to bring more people into the fold. Copilot is DPE, right? An IDE is DPE, right? I mean, again, you're using engineering principles to remove impediments to productivity from developers. It's not productivity management, right? If we're like leaning on developers to try to crank out more lines of code, or we're looking at, you know, whatever it is, some people-based or process-based solution, that's probably important and good, but it's not DPE, right? So that's kind of what makes it definable, is that if we're looking at the tool chain specifically and improving the tool chain, and that's how we're making our developers more productive. Yeah, great questions, awesome questions. Shirt or hat?
Oh yeah.
So you gave some examples from basically the top dogs of what we call tech organizations, right? But do you have any case studies from, let's say, companies who had trouble with, specifically with this problem? Because we also do. But not many companies focus on up until to this level because their focus is mostly towards product and functionality development. Do you have any use case studies that you can share that actually putting together this in an organization have helped?
I have public studies. I don't get into them in like this context, you know, because it starts getting a little pitchy. But yes, I've got Aetna, Goldman Sachs, about to publish a blog on Amex and Capital One. Yes, and if you want to reach out, I can send you those case studies specifically. I leave them out of this because it's not in me the right context. It feels icky. So. Yeah.
So basically, in short, the goal is to tighten the repo loop for at the organization level.
I think that's fair, but we're very much focused on the code build test, right? So whereas you got your full continuum, we're really looking at just the value stream, the part of the value stream that involves like writing and producing code, if that makes sense. Yeah, you want these shirts? We got shirts. You were the first two. Yeah. Oh, there you go. Oh, there you go. Okay. Oh, there's a queue. Yeah.
How is that different from like Make back in the day for compiling C?
It's not all that different because Clang and GCC have had build caches involved too. So,
so why hasn't Java had this decades ago?
I don't know. It's a good question. Good question. Any Oracle folks here? Yeah. I don't know why. Why did we start with Ant?
Because XML was hot at one time, and everybody thought XML was the answer. That's why. So the other part of that is I tried to build a build system for Java in around 98 or so because of that. And what I ran into is developers just putting in circular dependencies everywhere. So you didn't have any place, everything was dependent on everything, and there was no way to control it, to stop them from doing that.
So that might get us closer to the answer, at least why was Gradle the build tool to do this, because we also introduced the directed acyclic graph, or DAG, which eliminates it calculates and then eliminates the idea of a circular dependency.
So it rejects it on error?
It actually builds, it's smart enough to say, okay, if I've got circular dependencies, then I'm just going to put this on the class path once, and I build a directed graph instead of a connected graph.
So, Michael, part of the reason why C and C++ have had that caching is because they do static linking of libraries, whereas in Java and other interpreted languages, it's always dynamic linking or lazy late loading of libraries. So the problem is much more difficult, right? So in C, you have static linking of libs. So you know exactly, and you can cache exactly what you need. Whereas with something like Java, where you have jar files, you do late binding of those libs. So it's not as simple.
But you win the stumper question so far, because that's good. So far, you're in the running.
Build cache question.
Sure.
So I've used a remote build cache in companies that I've worked for before. When we had like our own data center, I just get somebody to set it up and run the build cache on the node. Now I'm working for a company who's moving away from our own private data center and deploying things in the cloud, running codes all in GitHub. We use GitHub Actions for our build. They're big into serverless functions and ephemeral environments. It's hard to say. It's kind of hard to sell. I need a VM out there running 24/7 with a build cache on it. Is that just something that they just have to bite and say, okay, that's a cost I'm just going to have to pay for if I want to get this increase in build performance?
That's a great question. So I mean, our nodes are Docker based, so they're a little bit more flexible, right? But still, the question remains. You just have to have this thing out there. I mean, yes. In fact, we've specifically had folks move from like Jenkins to GitHub Actions and then use a combination of the build cache to figure out first, oh wow, our dependencies aren't caching. Well, of course they're not, because the environment's blowing itself away every single time that we run a new build. So this is where the JFrog Artifactory, this is where the Sonatype Nexus solutions have come in, to provide a remote dependency cache that can still be utilized by these ephemeral environments. And then the same is true for the remote build cache node. Yeah. I don't know of a better way to persist it. I mean, you're able to store it all on S3 storage now. I guess it makes it a little cheaper and faster at least. So, yeah, no, good question. Very good question. But Pratik didn't have to help me answer, so you're winning still. So,
All right, folks.
We got time for one more, or are we done?
Go.
Yeah.
Yeah, absolutely. All right, that's Pratik's exercise. He's faster than I am.
He's in good shape.
So my company, we still use an Ant. Our build takes about 20 minutes. Unit test about an hour and a half. So where's the best place to start?
Well, you are tracking those metrics, and at least somebody can see that it's taking that long. You're in a bit of a tough spot. I'm not going to lie, right? Not a lot of new solutions coming out for Ant, for better or for worse.
If we can change a build system. So our company everyone else is on Maven.
Okay.
But I like Gradle. You got any selling points on one over the other?
Sure. Well, so first of all, we got to be clear, because I'm on the enterprise side of the house. Maven, Gradle, use what you want. I know that sounds weird coming from a Gradle guy, but we're actually trying to build this DPE platform to be very inclusive and open. Like, we just bought a company called Triple Quote so that we could easily bring SBT support into it as well. So now we're looking at Gradle, Maven, Bazel, and SBT, and we want to keep being more inclusive, from there. So I would say that if your company's already standardized on Gradle, on Maven, that it could be that the cost of migrating the whole system is not going to be worth it when you could move your whole system to Maven and still get all these benefits that I just talked about, right? That said, I would be happy to talk about the merits of Gradle as opposed to Maven, and I'd say the pros and cons on both sides, right? Gradle's not perfect, and it has a very steep learning curve. Some people really want a declarative syntax. Gradle is not a declarative syntax. It gives you the full power of Groovy or now Kotlin in our DSL. So you can do great things and you can do horrible things, and there's no guardrails, right? So then again, we got a configuration cache. It speeds things up considerably for configuring large builds. We have, like I said, the incremental build system baked in, local caching baked in. There are some definite advantages, but it's not my job to sell you on one or the other, to be honest. It probably sounds like it would be easier to move those Ant builds into Maven, which is at least standardized, and then look at whether it makes sense to then take everything to Gradle. I don't have any build tool people here, so I'm not going to get shot. So. What? I couldn't hear you. Next. I'm sorry. I'm having I'm trifold deaf in this ear. You're going to have to speak up louder next time. We can talk about that one over drinks.
We have one other question.
Continuation of that. So do we have anything on Maven local cache?
Yes, there's an open source Maven build cache available, which was made generally available in late October, early November of last year. So it's something where the extension's available. If you go through the advocacy thing that we talked about, the DP advocacy, part of what you'll go through is what's called our Maven and Gradle build speed challenge. A little bit of a mouthful there, but it actually will allow you to hit a public instance with a cache node, and you can get a sense of what your savings are going to be. So you could also do that too. But no, there's an open source one available for you.
So we have to, like, it's like a plugin. We have to plug in and then try out in local, and then we can promote it to like remote, right?
Well, so the open source Maven build cache has not got a remote build cache node support yet. I'm sure they're working on it. The one we provide does allow a remote cache node, and that's the one you can try out using the speed challenge if you want. I imagine they're going to get there. They just need to work all the kinks out of the local cache first. Yeah. That's right. So for those who don't know, we donated an instance of Gradle Enterprise to the Apache Software Foundation. So yes, the Maven project will be building against Gradle Enterprise, which is, I love it. So.
I use just so you can steal its ideas.
Sure. I'm all about that. It's open source.
S-cons. You've probably never heard of it. S-C-O-N-S.
Can you Slack that to me, Vince?
So
Thank you.
It's written in Python, and it scans the source, and it builds an SQLite database of all the dependencies.
Oh, very clever.
The backing is an SQLite database with the dependencies in it.
S-cons.
And then it says, okay, now build. And it uses MD5 checksums to determine if things change.
Nice.
You can tell it to use time sequence instead, but it uses MD5 checksums.
I trust the MD5s. Finally!
See, it's the best, I think it's the best build system for C because it knows about header files automatically. So you don't need to maintain the relationships of header files. That's all.
I'll definitely check it out. Yeah.
And then in addition, it's really smart because if you do if-def include header file, and if it knows how to handle that. If you're wrapping your includes in an if-def, that could be,
that's really flexible. Yeah, yeah. That's super cool. I'll check it out.
The next
S-cons.
thing that's cool is it knows which build rule it used to produce the code. And so if you changed your build rule, it tells you to
Wow, so very smart.
Yeah, you build.
So not just looking for structural changes, but even configuration changes like that. Very smart.
I just started on GitHub.
I
just started on GitHub. We don't start S-cons on GitHub.
Yeah, we get 35, 40 stars right now.
The thing about it that's cool, now you just my train of thought, is it's written in Python, and the configuration file is just Python.
Oh.
So you've got all the power of Python.
So that took a page, that takes a page from Gradle, actually. So, yeah, interesting. No, that's very cool. I'll check it out.
So it's cons or something, and then the Python guy.
Oh, I'm surprised I didn't know about cons. I was a big Perl developer back in the day, back in the 90s. So. Interesting.
All right, well, folks,
Thanks
thank
for
y'all
that.
for coming.